Hi, welcome to the GDC video where we are going to show a quickly discussion of the GNU debugger GDB. The first comes to talk about is debug monitor, and we want to talk about debug monitor, remote debugger, and GDB. Well, the debug monitor is a small program located in a non-volatile memory on the target hardware, and a debug monitor allows to download and run specific software in RAM to debug a program. The debug monitor permits the communication between the target and the host, and this is accomplished by serial or network connection. Then the debug monitor helps the process of remote debugging. So the remote debugger is able to download, execute, and debug a program from the host to the target. It's also called cross-platform debugging, and in the host, the remote debugger has a user interface to express different requests, and those requests the target handled and responds. This is from the host. And there are host requests, and those requests are combination of low-level protocols such as read X memory, write register X, add register Y, and so on. In conjunction, those low-level protocols accomplish single-step in breakpoint and program downloading. So a remote debugger is a low-cost software to download applications in embedded systems regarding embedded systems, but it has some advantages. One of the major ones are the inability to debug started code. And GDB in Linux distribution, one of the principal debuggers is GDB, and GDB is the GNU debugger. It stands for that, and it performs local debugging, but it also it's able to remote debugging as well. The debug monitor use it when we debug the target in the Linux distribution is called GDB stop. Okay, we're going to do some tests in GDB. First, we need to go to the project folder. Is cd strings. Next, open a file with a test editor. Let's call the file manager. Here we have. I just want to see the code. It's just a sketch. And then we're going to compile from the terminal. It's going to be in this way. G++ std 11. std C++11 is used to add the C++11 new features that aren't added by default. GGDB produces debug information based in the GDB debugger. Now the O flag is to create an output file, and represented by the name of output. And this is the input, the CPP file. Next, let's initialize GDB, passing the output file. Next, we're going to create a breakpoint to two functions, print word by word and main. And the main. We're going to run it, and we reach the first breakpoint where we can type L, and it's going to present the list of the source of the new sentences. We can step inside the function. It's going to show the sentence, the current sentence, and we can move forward by end that express next instruction. Next, I reach the next breakpoint. You can still say next, and you can see that is regarding the function that we are calling. Use next. I think that this is everything that I want to show. If you want to conclude the execution, you can create C to continue. It's going to show a split set of arrays. So this is the end of the video, and I'll see you next time.